In this example, we're going to be looking at number 9.73 from the book. It's on page 356. In this example, we'll be doing a t-test for the mean and a z-test for the proportion. But let's get to the problem. It says, an auditor for a government agency is assigned the task of evaluating reimbursement for office visits to physicians paid by Medicare. So this is a medical question. We want to look at office visits. In fact, they did an audit. It says the audit was conducted on a sample of 75. So I'm going to say N equals 75. I'm going to start writing down the information I've got. Next, it gives us some bulleted information points. It says 12 of the office visits had incorrect amounts for reimbursement. And so I'm going to write 12 incorrect reimbursements. Okay. It also says the amount of reimbursement had an average of $93. So my sample mean from this 75 says that it's equal to 93.70, and the sample standard deviation was 34.55. Okay, so I'm just listing out these values so that I know what the statistics were. This is different from other problems where we're just given the data. Here we're given the summary statistics. Okay, now part A. Part A asks, at the 0.05 level of significance, is there evidence the population mean reimbursement was less than $100? Okay, the level of significance is 0.05, so I'm going to list alpha equals 0.05. It also says that the mean, wanted to know about the evidence of the mean being less than $100. Alright, now that would be like a claim, since there's not an explicit claim being made, so we can go directly to the hypotheses from this point. Since there's no equal sign in this statement of evidence, we want to say that the alternative hypothesis is that the population mean is less than $100. H sub 0, the null hypothesis, is the opposite, mu greater than or equal to $100. The next step in this problem is to decide what the appropriate sampling distribution is. Clearly these hypotheses are relating to the mean, so it's either going to be a z-test if we know the population standard deviation, or a t-test if we don't know the population standard deviation. And if you look at this problem, nowhere in this problem does it give you the population standard deviation. So we know that the population standard deviation is unknown. Sigma, unknown. And so that means this is going to be a t-test for the mean. Okay? And in most cases you won't have the population standard deviation. Now, the next step, we need to decide which tails are involved in this test. Now, this is a one-tailed test because we don't have inequality here. And so we're going to draw the rough graph, the distribution. Okay, and that's kind of ugly, but that's okay because it doesn't matter. The alternative hypothesis says that the mean is less than $100. And so if I use the shortcut, this less than sign is pointing to the left, and so I'm going to shade in the left for a left-tailed test. So this shows that it's a left-tailed test. We've already learned what alpha is. We've already learned what the sample size is. And so going from here, we can quantify the rejection region explicitly. Since it's a t-test, we're going to need degrees of freedom. So degrees of freedom is going to be 74. If you're not sure where that came from, notice that my sample size is 75, and the degrees of freedom is equal to n minus 1. So that's where I get 74 from. And so with this, I can now get the one-tail critical value here. Critical value for the left-tailed test. And so I'm going to jump to minitab to do that. And in minitab, I go to graph, probability distribution plot, and I view probability. Then I select the t distribution. In this case, it was already selected. I type in the degrees of freedom, which was 74. Then I push shaded area tab. The probability needs to be chosen, and as we just saw, it's a left tail test, and alpha is going to be on the left tail. So our alpha was 0.05. I'm going to enter that in and hit OK. And we have our left tail critical value, negative 1.666. So that's the value I'm going to use on this example. Okay, so this is negative 1.666, and that defines the rejection region. Okay. Now we don't necessarily have to use critical values. We can use the p-value approach, which I prefer actually, but I'm showing it to you just in case you're doing the homework online and it asks for the critical value. You can find it. Okay. Next, we have got to look at the statistics and compute the test statistics from those data points. And since we're already given the x bar and the s, we can compute those in minitab. We need the t-stat to see where it goes up here, or we can get the p-value to compare to alpha. And I'm actually going to use the p-value approach, even though minitab gives us both approaches. Okay, so I'm going to go to minitab again to compute the test statistics. And in this case, I go to stat, basic statistics, and I go to one sample t, because the population standard deviation is not known. And in this example, the data has been summarized for us already. We know that the sample size was 75. The mean of the sample was $93.70. And the standard deviation is 34.55. Okay, now we're going to perform a hypothesis test, and in our hypothesis we're looking at the cutoff point of 100. Next, we need to look at the options for this hypothesis test. The alpha in this example was 0.05, and so our confidence level needs to be 1 minus that. And our alternative, in this case, since it's mu less than $100, we need to choose less than as the alternative hypothesis. Then we hit OK, and OK again. And now we've got the critical value, t, negative 1.58. We've also got a p-value, 0.059. And in this example, I want to use the p-value to decide whether I reject the null hypothesis or fail to reject the null hypothesis. I'm going to go back to this problem that we've been working with. And so we notice that the p-value is equal to 0.059. And we want to compare that with our alpha value, which is 0.05. And it is actually greater than 0.05, which is alpha. If you remember the rule, since if the p-value is greater than alpha, we fail to reject the null hypothesis. In other words, we don't have enough evidence to reject the null hypothesis if the p-value is greater than alpha, which in this case it is. You'll also notice that we've got a t-value of negative 1.58. You'll notice that is just to the right of the critical value in the non-rejection region, so we fail to reject the null hypothesis. And to formalize that, I say fail to reject null. Not enough evidence to say that the mean is less than $100.